So today you guys are witnessing history. What is that? How am I supposed to work on the floor with this in the way? Anyway, thanks to a gentleman by the name of Jeremy Fielding, who has an amazing channel about motors. I mean, just totally dedicated to anything and everything about motors. And the way he explains stuff is just wonderful. If you haven't checked it out, please do so, Jeremy Fielding. On his channel, he shows how to wire different types of motors, and he also talks about different types of motors. And the washing machine motor being one of them. This is an induction motor. It's an AC motor. And what I've learned so far is that it basically uses two types of wires. So it has a set of wires dedicated just for starting, and it uses something called a starting capacitor. This is just used to start the motor and then is no longer needed. I don't know the details, but I think once the motor spins up to 20% or 25%, there's a special type of switch in there, centrifugal, I believe, that shuts off the starting circuit. Now, I think that's a 2-wire circuit. And the other wires in here, minus the starting wires, are for the different speeds, because the way we control speed on this motor, according to this washing machine, this says that it has 4 speeds, but I was talking to some people on an electronics forum, and they think that it only does 3 speeds, and 2 of these happen to be the same. But basically, the way we control speed on this type of motor is by supplying power, voltage and current to a certain number of coils, and there's different wire combinations. Now, something that I found in this washing machine was a map, but this is basically like a wiring schematic. I'll post a picture of it, and I think here are the different functions or maybe troubleshooting codes, but it has a wiring diagram, so I can't read wiring diagrams worth beans. This one isn't that complicated. I'm going to do some wire tracing using this and using Jeremy's procedure of testing resistance on these wires. Actually, I think we can unplug this, and then we can test resistance across these wires, and the one with the highest resistance, or the wires with the highest resistance, are for starting, because they're a thinner wire which has more resistance, and they're not expected to supply power for that long, only for starting the motor. Because this is a single-phase AC motor, single phase by itself won't spin the motor. So technically, we don't need a capacitor to start this motor, because we can just turn it by hand once we supply power. It's probably not the safest and the smartest way to do it, but you can. And the way, whichever direction you spin the output shaft here, that's the way that the motor will spin. So you can spin it clockwise, and it will start and spin clockwise. And then when you turn it off and turn it back on again, it won't spin without a capacitor, starting capacitor. So then you spin it counterclockwise, and now it will spin the opposite direction, counterclockwise. So that's a neat thing I just learned recently. So I'm actually going to start by labeling these wires, just the wire sets, and I'm going to unplug them and try to make some sense out of them. Okay, so it's like this. The big plug was here. So water level, temperature, so rinse options. This is our speed controller, speeds. And what I was thinking with this motor, this is a bit of a tangent, and it's probably a completely insane idea, but Since we have different speeds, I'm wondering if I was to somehow mount this on a moped or a go-kart or a bicycle and find a way to provide AC power to it, you know, using like an inverter or something, DC power to AC and then to the motor. If I could just use like a twist handle with, you know, that's how you shift. That's how you shift gears on some bikes, and also if you ever rented an electric bike, I think they have speeds like that. So of course I would have to figure out maybe some sort of a clutch or freewheel, but I could go from 1, 2, 3, 4 and just jump the speeds that way. Other ways of controlling motor speeds is by pulleys, so it's like a mechanical solution, but right now I'm focusing on this motor and learning more about it and the electronic solution. So one of the first things I want to do is still divorce the transmission or transfer case or gear reduction on here from the actual motor itself. See how it has this big old appendage? And I don't know if it's as easy as removing these bands. So I'm gonna try that. Maybe it's just that simple. You guys see my screwdriver? Wow. Oh, this is amazing. Check it out. I was really dreading divorcing them, but you know, California is a no-fault divorce state, so that was easy. Some sort of couplings here, and I read about these things breaking. So yeah, this must be our 4x4 differential. I'm sorry, 4x4 transfer case. You can tell I'm not a four-wheeling dude. This is awesome. I should probably weigh this. Wow, that's great. Okay, thank you. Good night. We're done. Okay, now we're cooking. She drew blood, okay? We do happen to have first aid kit on hand. Always have a first aid kit on hand. Never know where disaster might strike. So just a dab of pretend Neosporin and we're good to go. So like I said, I'm going to labelize these. So this we'll just call it level. Level, that's French. I hope you guys can hear that weed blower or whatever that is in the background. It's making videos outside is awesome, especially when you live in like a HOA dense suburb like you're a weekend warrior like me, and I can reach out and touch our neighbor's house. Fortunately, I have a cool neighbor. Okay, so unplugged level, and I don't know why they always tangle this stuff. It's like there's some poor intern whose job is to just tangle stuff. So this next one is going to be temp, as in temp agency. And this one here lives awfully close to the circus board, but I don't think, no, this one's next to it, but this isn't the one that's going to the circus board. It looks like the circus board has its own thing. And naturally, one guy, you know, one MIT grad is sitting in the basement of Mr. Kenmore's house, and his job is to tangle the wires, and his partner, her job is to come up with completely unique plugs for every single connection. No two plugs can be alike. Okay, so then we've got this one here, which is a circuit board. And this is interesting because I think I can. Yeah, I just unplugged it. That's kind of neat and interesting. I think I can pick up that there's 1, 2, 3 capacitors. These rainbow dudes. Wow, there's a lot of rainbow dudes. I think the rainbow dudes are resistors. The band signifies something, miles per hour or something. And then this caterpillar thing is probably some sort of a processor chip. Made in Mexico for real. FSP. That's cool. So put that there for safekeeping. And so there's this next set. So I'm going to call this one printed PCB, printed circuit board, just because that's how I roll. Okay, circuit board is out. There's a shared wire here, of course. That's going to make tangling and untangling impossible, I'm sure. And then that brings us to 1, 2, 3, rinse. The good old rinse, lather, repeat. And I think what I could be doing is removing these guys, like, how do you, don't tell me these are pressed on. But I can probably save these switches. These switches look pretty cool. I really like this design. So rinse is next. And then we have all this jazz here. This is the control stuff, actually. I wonder if I unplug this major plug here, if she'll still fire up. Okay, so I just got that. So that helped me untangle it a little bit. But I've got this switch here, and as far as the switch goes, I think no matter what speed I have, it will still spin. It just will spin slower or faster. So I'm going to bypass like the lid being closed. I don't care about that kind of stuff. Yeah, so I think this guy here is for the different speeds. I'm going to try to be a minimalist and actually remove all of this. Okay, so I'm going to be checking resistance using my ohm meter here. Okay, so right there, that's 5.1 ohms of resistance, and that's across whatever that guy is in yellow. me look at my map. So they're basically saying that the start should have a resistance of about 8 plus or minus 3, and the high speed is 1.7 and a low is 2.6 with like a plus or minus of 0.8 or 0.7. So, and according to this thing, it looks like let me get my plug. So I'm just doing this so we can see what's what. And this wire here, let's actually make them so they match. So this wire here is red. So this red wire would actually be connected to black wire coming out of the wall. Black wire on one phase is hot and white is neutral. So then it goes through the starting capacitor here, and what we're supposed to do is check for resistance. And I'm using these alligator clips. I could use the little pointy probes, but that's fine. And as I go through all of them, once I get to the yellow, it starts reading, and the other ones don't. And I like to use these because you're supposed to allow that resistance to build up. So I can just clip it like that, and then we can see it. So we can say that I'm going to call that yellow, red, and it's 5.1. And I think we're supposed to check all of them like this. Now, what is this next guy? So this next guy here is orange, right there. Just going to use the same type of. So that's a. Let's see if I can clip it. So there's our 1.7 on that one. So that's white and orange. .7, and according to this thing, that would be the high. And then let me keep going. So this one like has nothing there. That's interesting. The blue and orange is a 0.4. White, black, and orange. White, black, orange. 1.7, so that's a high. That's interesting because this guy here, this black one on the end, like there's nothing to clip onto. So there's actually nothing coming into that black one on this guy. Interesting. I think you're supposed to go through all of these. Nothing. Okay, blue. and white is 1.6. And then white black and white is, call it 0.3. Yeah, I'm not quite sure what that black one is doing because there's a black wire right there, but there's like no clip to it and nothing coming into it from the plug. Okay, so which one is this? So this is 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this would be green, yellow, and there's nothing. Green, yellow, and A. Yellow. And A. So now I'm going to try. So white and black with blue. It's 1.6. Okay, white. Okay, so now this is probably impossible to read. Can this focus? Focus, you silly thing. So this is our resistance. And looking at this guy here, it looks like indeed we need to connect the red to the yellow for the start. So the red is here. I think I'm gonna get some female blade terminals to slip on there. Yeah, I think I'm going to do that, but I know that I need to connect my hot from the wall from a single single phase power. Black will go to the red, which will come in on here because that's this wire. So basically it will go to the capacitor, and it also supplies power to the yellow. So it's and I think the white and black as well. Let me regroup on this. Okay, so having done a little bit of research and looking at the wiring diagram here, I can tell that certain wires are part of the start circuit. So obviously the ones with the capacitor. And so what I'm going to do is I'm going to cut this out from this main switch here, because I'm not going to be plugging into that big old whatever it is. So I know that this will get the hot wire from a from my outlet. So this is the cord, and it's the one with the ground. So it's got one's got a rounded, one's got a kind of squarer edge. So that one I know will go to this, okay? And then that's the starting circuit. The yellow wire will be the neutral. So the yellow is coming off of here. I'm going to keep this plug to plug into the motor just so I don't have to make my own blade connectors. But then if I follow the yellow runs to the same plug, obviously, so I'm going to snip that one as well. And I know that now, at this point, I would connect this to the white on my mains here, single phase, which would be white. So I'm going to strip it and connect it, and I have these types of connectors. This is just temporary, and I am going to use a surge protector because it has a switch so that I can actually flip that. So the yellow and the red take care of our starting circuit, but that's only to start. If we just wire this, it won't run because there's no continuous power going there. So we have to then decide which of the other wires we want to use to have it spin. Looking at this thing, there is a white with a black stripe that would go to the neutral. So white with black stripe, that's here. I'm also going to cut this guy out. So that one and yellow would go together to the white from the wall, if you will. Now there also appears to be a white wire. That's interesting. That white wire looks like it's running to a bunch of things, including the circuit board, but it doesn't go to the main connector. So that's interesting. There's a white wire, but it doesn't go to the main connector. I'm going to snip this one off as well. And this white also goes to our white from the wall. So now we have a total of 3 wires going to the white from the wall, if you will. So we have a yellow, a white black, and a white. There was a gentleman on All About Circuits website goes by the handle of Low Q Cab. I want to thank him for helping me out with this and actually sort of putting this in layman's terms. So I'm following your diagram, trying to follow that and kind of follow my own logic here. Hopefully we'll get this motor spinning today. I don't mind admitting that I need help. Obviously I do. This is my first take at it, and yeah, Jeremy Fielding did a great job of showing us how to start these on his own YouTube channel, so that's helpful too. So I'm actually following both of those guys' advice. So it looks like I'm also supposed to use the black, but I don't see it here, so I don't know how. I guess that's sort of like an internal connection here, maybe. So I could try the wiring that I have there and see how that goes. Okay, so I got a clamp here. This ends are plastic, so that should be fine to hold the motor down to the table. Which way should I do this? Maybe this way. Let's see if this would work. It would be cool if this worked. Okay. So we will be plugging this back in. Not using these other ones, but I'll plug these in. How the heck do these go? Okay. And basically these three go to the neutral. So neutral is the larger of the two. So I think it's this one. So I gotta shove all of these four actually in there. I think I'm gonna go for the bigger one. Okay. And that leaves me with the hot. And the hot on this one just goes to the capacitor, and then it gets connected to a black wire after the centrifugal switch or something like that. I'm going to use a yellow on this. Okay. So these are plastic pliers in case I have to give this motor a spin, maybe, because it might hum. But here we go. Plug it in. Yeah, it's humming, so that means a bad capacitor. I don't know if you guys can hear that. See if I can spin it. Did you guys see that? I manually started it. Let me turn it off. So I think we have a bad starting cap here, okay? Watch. When I turn it on, it hums. And then I started manually. See that? It works. So I turn it off, and I spun it from the back because there's a plastic sort of a bushing here, so I'm not touching metal, so I felt a little bit safer, but I can touch the output shaft, if you will, because that's part of the rotor, not the stator. But turn it on. It's got to be a bad cap. So this is one of the speeds. Pretty cool. Now just to figure out how would we manage to get the other speeds going. I'm going to unplug it. So it's really interesting. I'm giving only power, like the hot is just the red right now. And then I have all these other extra wires. I think I'm going to cut them off the plug. So here's this violet and white. Which they are claiming is a medium signal. Orange should be low. I reckon. White orange is off of this. That's interesting. I think they're using this switch here. Washing action switch. That's what it is. So the white orange are these and the white violet are these, which run to this switch. And I'm wondering if I was to plug this in and give these guys hot, if that's what would make it spin. But then I'm confused why I also have all these extra wires here. I have a blue one. And so the blue goes to the switch here. The blue actually went to the speed switch. There's a green. So this green here looks like this is a ground. So the green and green and yellow is a ground. This may be just something that I will connect, ground to ground here. All right, so what are these extra wires here? So green we know is a ground. And we are left with orange and blue. And then it's violet and white. Maybe what happens is you can wire the motor directly, maybe, to get certain speeds, or you can go through this this switch. That switch looks like it goes on the inside. That's interesting. So I see there's an orange and a blue that want to go to the centrifugal switch. I think the blue is high. And I don't know how this works. There's this table. Can you guys see that? Does it focus? There's a table and it says X means timer switch may be open or closed. So there's a low, 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 high, 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 and X low, low. Low, low looks like it's, what the hell does that mean? B and C. Yeah, I don't know. I don't know how to do the I don't know how to do the speeds on this motor yet because of the complexity of this additional guy right here. Like there's a way to do, I guess, to do it with that switch. Yeah. Okay, so I think I'm just gonna wire the green yellow to ground. And let's try it again with let's try it again with the ground wire. Hopefully that didn't break anything. So here, I'm going to try to turn on the power while the motor is already spinning, okay? So, yeah, and it goes. So cool, man. This is so much fun.